started a lesson, trigonometric functions. In this topic you have learned the concepts, solutions of trigonometric equations, the two types of the solutions. One is general solution and second is principal solutions. Technique for finding the principal solution and general solutions are explained in the previous videos that you can check in my list of the videos. In today's session we are starting next concept related to the Cartesian coordinates and the polar coordinates. Let us see geometrically. X-axis, y-axis, intersection, that is the origin. Suppose I am taking here point as the P of x, y as a point in the first quadrant. The coordinates of the points are given in terms of the x, y. They are called as the Cartesian coordinates. Join the point P with the origin, getting the ray as the OP. For this ray OP, distance from the origin, that is known as the polar distance, denoted by the R, and angle made by this ray OP with the positive x-axis, this angle is theta. Then the construction part is draw perpendicular from the point P towards the x-axis. Perpendicular is drawn from the point P towards x-axis. Then put a perpendicular point as the M taken here, check. From this figure we can write the measures of the sides for the triangle O and P. Length of the OM from the coordinates P of xy, length of OM is x, and length of EM it becomes y. Then using the formulas for the trigonometric ratios, taking here first one, cos of theta expressed as the adjacent side upon hypotenuse ratio obtained here, x divided by r. And second ratio we are taking here, sine of theta, that is given as the opposite side with the hypotenuse. So ratio is y upon r. From these relations we obtain the value for the x and the y. Let us see in the first ratio, cos theta is equal to x upon r. R shifted to the left hand side will be get multiplied to the cos of theta. Hence, x is equal to the r cos theta. And second relation is y is equal to, check this, r get multiplied with the sin theta, so it is equal to r sin theta. So two equations are obtained. One is x is equal to r cos theta, and the second y is equal to the r sin theta. Then we use one more trigonometric ratio and the Pythagoras theorem. Check here, the triangle OMP is a right angle triangle. By Pythagoras theorem, r square is equal to the x square plus y square, sum of the square of other two sides. From this relation, r is equal to the under root of x square plus y square. Value for r is obtained. Now remaining is the angle theta. To get the angle theta, we use the trigonometric functions. That ratio gives values of x and y. Observe, x is the adjacent side, y is the opposite side, trigonometric ratio tan theta is applicable. That gives the relation between opposite side and the adjacent side. So writing next formula also as a tan of theta is equal to the opposite side divided by the adjacent side, that is y upon x is the ratio. Therefore, from this relation, value for theta is expressed as tan inverse of y upon x. So two more formulas are obtained here, that is value for the r as a root of x square plus y square, and second theta is equal to tan inverse of y upon x. The examples related to the Cartesian coordinates and the polar coordinates can be asked as: first type, if you are given r and the theta, then find the value for the x and the y. I repeat, value for r and theta are the given, calculate the values for x and y. That is, polar coordinates are given, find the Cartesian coordinates. Now reverse, Cartesian coordinates are given means value of x and y are the given, we can find out r and the theta. This conversion known as the, if you are given the Cartesian coordinates, finding the polar coordinates. By using these formulas, Cartesian coordinates change to the polar coordinates and polar coordinates can be changed to the Cartesian coordinates. The important thing is related to the angle theta. Here point is in the first quadrant, so angle theta is obtained, acute angle. But if you are given that point P in the second quadrant, third quadrant or the fourth quadrant, that will be decided by the signs of that particular point, positive, negative signs. If both are negative, obviously the point goes to the third quadrant. In that third quadrant, angle is more than the pi. So for that angle theta, formulas you can apply pi plus theta, pi minus theta or 2 pi minus theta, like that. Let us see the examples. Example number first question. First, find the polar coordinates of the point whose Cartesian coordinates are first example, Cartesian coordinates are given as for the point P 2, 2 root 3. Point P is given in terms of the Cartesian coordinates. Question is find out the polar coordinates. Let us see the method for solving the sum. Solution. First, write the given point as it is. Given point P of 2, 2 root 3, that is the Cartesian coordinate x, y. Compare, you will get value for the x is equal to the 2 and value for y is equal to the 2 root 3. Value for x and y are the given. From these values, we have to find out the r and the theta. See the formula for the polar coordinates r and the theta. R is given by root of x square plus y square and theta equals to tan inverse of y upon x. So writing here, therefore polar coordinates are formula r is equal to under root x square plus y square. Check. And second, angle theta is equal to tan inverse of y upon x. Value substitute for the x and y in the problem. It is equal to under root of x square, that is 2 square. How much? Okay, 2 square, right as it is, plus y square 2 root 3 bracket square. For simplifying this, it is equal to the root of 2 square is the 4. Next again 2 square 4 root 3 square 3. 4 3s are 12, and 4 plus 12 addition is obtained 16 root of 16. It is equal to the 4. So r is obtained 4. Second value for the theta, substitute values of y and x. Tan inverse of y is 2 root 3 divided by the x is 2. So 2 get cancelled from numerator denominator. Remaining is tan inverse of root 3, and tan function is root 3 for the angle pi by 3. So theta is equal to the pi by 3 radian. So you have given Cartesian coordinates x, y. We have calculated the polar coordinates r, theta. After getting this value, just write the sentence as the polar coordinates of the point r, p of r theta, that is the 4 comma pi by 3. The final conclusion. The polar coordinates are p of r theta is equal to the r value is the 4 and theta value is the pi by 3 radian. This is the answer for the given problem. The polar